So some more properties on definite integral. So we've seen these in some of the earlier videos. Now we are going to look at this one here. So if you have a function f of x, so that's this function here. If you have f of x, if f of x has a maximum value, max f, so the maximum value would be the highest value here. So this here is your max f here, okay, and a minimum value min f. So the minimum value would be the lowest point, and then this is your min f here. So this is your min f, okay, on the interval a b. So on the interval a to b, okay. So if this here is the case, then the true area of the function, so that's this area here, then the true area, so that's this area here. So the true area is always trapped between the minimum, so the minimum area. So so the minimum area would be this, okay. So if you look at this here, b minus a would give you the length, okay, and then you times this value here. This value is the minimum value of a within our interval here. So this is min f here. So min f really represents a height. So now if you get the height times the width here, b minus a, so width, then that would give you the red area here. That would then give you this area here, okay. And then if you look at this now, the max f. So max f. So basically this area here is given by this, okay. It's given by this. So when you look at this, hang on, bear with me. When you look at this, max f here is the highest value within our interval. So that's this point here. So this is our max f. So max f is really the height here, and then you times the width here. You times the width. Then if you get this thing times this thing, that will then give you the area. So so this whole thing here is the area, the green rectangle here. Okay. So what it's saying here is that our true area here, our true area, which is this one here, is always trapped in between the biggest possible area and sorry, the true area here is always smaller or equal to the big area here, and then but the thing is the true area here is always bigger or equal to the smallest area, if that makes sense. I hope you can see it. So it's like that. So hang on, let me try and show you this again one last time. So the true area here is always bigger than the smallest area, but it's always smaller than the biggest area. Okay, it's kind of obvious if you think about it. Okay.